Hello students, welcome once again to our channel Physi Dive, and this is your teacher Alexi Rajan. And today we are going to start a new topic for class 9 NCERT, and the topics are speed, velocity, what are the different properties of speed and velocity, are they same or different, and the next thing is that what is acceleration, what are the different types of acceleration, uniform and non-uniform accelerations. So let's dive in straight to the class. So the first topic, that is speed. What do you mean by speed? So speed is nothing but it is a physical quantity that determines how fast an object is moving. Consider two objects. This is object A and this one is object B. So just imagine that these two objects are moving from the same origin. Now, this is a starting point and this is the ending point. You have a clock in your hand and see what happens there. Both the objects, say object A and object B, both are starting from the same point. Now, I have just started the clock, the stop clock. So they started running and you can see this particular object A is also moving and object B is also moving. Once the time reaches here, okay, or after 10 seconds, just imagine that it's 11 seconds, okay. After 12 seconds, you can see that object A had reached this particular point, end point, whereas object B is still here. So you can say that object A is faster, or the time taken by object A is lesser. It has taken by 12 seconds, the object A has reached the end point, whereas object B is still here. It would have taken, just say that it had taken 15 seconds. So here you can see object A is faster, and that faster, or how fast an object is moving with respect to time, there comes a term that is speed. So speed is how fast an object is moving. So that's all. That is the physics behind, the story behind this term speed. Now, the term speed, whether it is a vector quantity or a scalar quantity, you know that vector quantity means any physical object or any physical quantity, it's not object, any physical quantity that is having direction as well as magnitude is known as what? Vector. Whereas any physical quantity that have only magnitude and there is no specified direction, we call it as what? A scalar. So now the term speed is a scalar quantity. There is no specified direction. It is a scalar quantity. No specified direction. And the third one is that what is the SI unit of speed? The SI unit of speed, we have seen how fast with respect to time, what is the distance traveled. This is what the speed gives you, right? So you can say it is distance by time is the equation. So you know the SI unit of distance is what? SI unit of distance is meter divided by time, that is second. So this is a SI unit, that is meter per second. So if you want to find out the speed, then if you know the distance and if you know the time, then divide distance by time and you will get speed. Where you have studied this equation in your 7th standard NCERT textbook, you can see this equation. And the SI unit is meter per second. So these are the basic things that you need to know while you study speed. So what will be the definition of velocity? So velocity, the first and foremost thing is that velocity is a vector quantity. So there comes the importance of direction. Speed of an object with a specified direction is known as what? Velocity. So there comes the importance of direction. With a specified direction is a term that should be coined there. So there comes the next property, that is, it is a vector quantity where both magnitude and directions comes into play. So, and the third one is that what is the equation as well as SI unit. So equation is what? Displacement by time. In your previous video, I can just coin somewhere here. I'll just put the link somewhere here. You can just go through that video if you want to see that. So here you can see it is a vector quantity. So definitely it is not distance by time. Instead, it will be displacement by time. And SI unit will be what? Same. Displacement SI unit is meter divided by time, that is second. So meter per second. same SI unit you can see there in the case of speed, and here also it is the same, that is meter per second. Displacement by time, there we can say it is position by time, or displacement is position change, the position change by time there. So this is all about velocity. The only change is that it have a specified direction. Now a very important thing, that is, what are the different types of velocities there? There are mainly two types of velocities, and they are uniform velocity as well as non-uniform velocity. So we'll just take one by one and see what are the different and how we can define this uniform as well as non-uniform velocities there. So first thing, that is uniform velocity. Imagine that an object is here, say a man is standing here and he is walking, and you are just dividing the time intervals equally. Okay. Now the position of the man at the origin is 0. Okay. With respect to this origin, this point is 2 meters away, and this point is 2 meters difference, that is 4 meters away from the origin, and this point is 6 meters, this point is 8 meters, this point is 10 meters, this point is 12, this is 14, and this one is 16. So this is a scenario there. Now just say that I'm saying the man is started to move, then he had covered these 2 meters in 2 seconds. Okay. Now the next 2 seconds he had covered 4 with respect to the origin, and the next 2 seconds the man had covered 6 meters with respect to the origin, and the next 2 seconds the man had covered 6 to 8, that is 8 meters with respect to the origin. So just imagine that this is a scenario. There you can clearly see that the man is covering equal displacement. The man is covering equal displacement in equal interval of time, and we call it as what? Uniform velocity. Now in the same case, same scenario, I'm not saying case, scenario, you have a person here, you have a time interval of 2 seconds. The first 2 seconds, just imagine the man had covered 2 meters, and the next 2 seconds, just imagine this person had covered 6 meters with respect to the origin, and the next 2 seconds the man had covered 7 meters with respect to the origin. Here you can see that if you consider equal intervals, then you can see that the man is covering unequal displacement, or the change in position with respect to the origin is different. Whereas in the first case, in this case, you can see that in equal interval of time, the displacement or change in positions is uniform. Whereas here you can see in the first interval, you can see the change in position is what? 2, because the man had covered or changed its position from 0 to 2, that is 2 minus 0, that is 2. Whereas in the second case, in the second interval, you can see the man had covered from 2 to 6. 2 to 6 means he had covered 4 meters. Difference is 4 meters. That you should take the difference because it is a change in position. Whereas in the next 2 seconds, you can see the man had covered 6 to 7. That is a difference of 1 meter. Change in position is 1 meter. So here an unequal displacement is covered in equal interval of time, and we call such type of velocity as non-uniform velocity. So the definition goes like this. So that's all about velocity and the different types of velocities. So now we want to study about the next very important term in motion chapter, that is acceleration. So the next term is acceleration, and the definition goes like this. Acceleration is the change in velocity with respect to time. Imagine you have a bike here and you're riding this bike. I don't know, you can just term your own, like your own favorite bike. You have a bike and a person is riding this bike. Okay, he is moving there, and you have one particular part in your bike, that is accelerator. So if you just give an acceleration, or if you just turn that accelerator, you can see that the speed of bike is changing. Speed of bike is changing, or the velocity of bike is changing. Once you can see, once I start the bike and if I just start riding, then if I just observe the speedometer, you can see a needle is there. First it will be 0, it will be written as 20, 30, 10, 20, 30, 40, like that. If I just turn my accelerator, you can see this particular needle start to move, and that represents what? I am just increasing my velocity with respect to time. As soon as I just give the accelerator, the speedometer reading changes. Its needle start to move. Its needle start to move from 0, 10, 20, 30, like that. And if I am applying the brakes, then from 60 it will just come to 40, 30, 20, 0 if I stop there. The velocity is changing with respect to time, and that is known as what? Acceleration. And now, what is the SI unit of acceleration? And acceleration is what? Acceleration have a specified direction. So definitely acceleration is what quantity? It is a vector quantity. And the third point is that what is the SI unit of acceleration? Acceleration means what? It is a change in velocity with respect to time. So definitely it is velocity by time, and we call it as what? What is the SI unit of velocity? It is meter per second divided by time, second. So it will be meter per second square. It will be meter per second square. So this is all about acceleration. In the case of acceleration also, there are two types of acceleration, that is uniform acceleration and non-uniform acceleration. We'll study uniform and non-uniform acceleration one by one and see what is the difference there. In the case of uniform acceleration, we can say that the rate of change of velocity is uniform, then we call it as what? Acceleration is uniform, or simply uniform acceleration. So a simple example, in the case of gravitational force, there is a particular acceleration. For example, if I have an object here, and if I'm just dropping this object, then definitely if I have an object here, and if I'm dropping the object, then I will see that there comes an acceleration. This particular body will have an acceleration, and it is denoted by small letter g, and its value is approximately 9.8 meter per second square. That means that object is having a uniform acceleration. Uniform acceleration. That means its change in speed is uniform. Change in speed. In each movement, you can see each time the speed increases uniformly. The speed increases uniformly, and we call it as what? Uniform acceleration. And you can, in the other case, that is non-uniform acceleration, the change in speed is not uniform. In nature, majority of the object is following this particular acceleration, that is non-uniform acceleration. Here, the change in speed, change in velocity. So change in velocity is not uniform with respect to time, whereas in the first case of uniform acceleration, the change of speed is uniform with respect to time. So that's all about acceleration. In nature, again I'm saying, majority of the movement or motion is non-uniform, whereas we can see uniform acceleration in the case of what? The case of a gravitational force. In the case of gravitational force, if I'm just dropping this object, then it will just come down, it will just fall down under the action of gravity with a particular acceleration, and we call it as acceleration due to gravity, and that is uniform. Its approximate value is 9.8 meter per second square. That means each second it is increasing its velocity, that is velocity at a rate of 9.8 meter per second. So we can say that is a uniform acceleration. That's all about today's class, where we have studied about velocity, what are the different types of velocity, what are the properties of velocities, and acceleration, what is acceleration, what is the physics behind acceleration, as well as what are the different types of acceleration, where you have studied uniform as well as non-uniform acceleration. We need your support with your like, comment, share, as well as subscription. Next class we'll come with a new topic. That's it. Thank you and goodbye.